Assalamualaikum warahmatullahi wabarakatuh. Hello, my name is Fauzan PUTRA, and for today I would like to explain about the polymerizations and structures of polymers. So this presentation I would like to explain you about the introductions, type of polymer structures, explanations about crystallinity, explanation about molecular weight, application and reference. So in these introductions, I will explain about the polymers and the polymerizations. Okay, so what is a polymers? Polymers means many, and mers mean units. So polymers is a many units. Polymer is a molecule made from many units of monomers. It is also makes a very large molecules by linking together small monomers units. A monomers is just a small organic molecule. A monomer can react with other molecules to form very large molecule or polymers. So this called is the polymerizations. Polymerization is a process in which several monomers molecules combine to procedure of polymers. So this process through which a large numbers of monomers molecules react together to form a polymer. And then we have a type of polymer structures. It is consists of four types. The one linear, second branch, third cross-linked, and the lastly is the network. So first, we have linear polymers. Linear polymers is made of only two repeating units that are linked together. It resembles the spaghetti with long chains. The binding forces of these entangled chains are weak van der Waals between the molecules and mechanical entanglements between the chains. The long chains are typically held together by the weaker van der Waals or hydrogen bonding. Even though these bonding types are relatively easy to break with heat, linear polymers are generally a thermoplastic. And also we have the example of linear polymers, which are Teflon, polypropylene, and polystyrene. And next we have branch polymers. Polymers are characterized as having secondary polymer chains connected to the main backbone. It is also similar to polymer chains that run in a straight line and have a short chains hanging off them like spaghetti. When side branches are made, the chain's packing efficiency goes down, which makes the polymers less dense. The property of these polymers are mainly affected by the amount of branchings. The substituents in another polymer chains are composed of covalently bonded monomers units. These side chains can be either short chains or long chains, and the chain's packing will be reduced by the production of side branches and decrease the density of the polymers. And the example is the starch, ketogen, low density polyethylene. And next, we have cross-linked polymers. Cross-linked polymers is a bond that links one polymer chains to another. This cross-link can be formed between either ionic or covalent bonds. Cross-links between polymer chains are stronger than normal bonds between molecules. This makes the polymer materials more stable and stronger. Cross-linked polymers can be found in the synthetic polymers and naturally occurring polymers. Cross-links can be formed from chemical reactions using or cross-linking reagents. The most common example of cross-linked polymers is the vulcanized rubbers. Rubbers is the vulcanized because natural rubber is not stiff and rigid enough. And then we have network polymers. Network polymers are the polymers that have a lot of links like them to form a complex network of 3D links. When these polymers are heated, it is almost impossible to make them softer without destroying their structures. The unique properties of the network polymers come from the way molecular chains are linked together, usually through permanent covalent bonds. Among them are the higher modulus of an elasticity, lower rate of creep, resistance to solvents, and stability at high temperatures. It is because a packlet is a phenolamine polymer. And okay, and then we have the crystallinity. So crystallinity is the degree to which the polymer chains are still aligned with each other. Then there is a solid level of structure's order and the arrangement of molecules or atoms is uniform and repeated. With this method, crystalline and amorphous zones can be made in materials like glass and ceramics. The crystalline region has a repetitive arrangement of molecules. Then the greater the crystalline content, the greater the hard and stiffness, but the lower of the ductility. Next, we have what is molecular weight? So molecular weight is one of the most central aspects of polymer properties. Of course, all molecules have molecular weights on their own. So what exactly is molecular weight? So molecular weight is a measure of the sum of the atomic weight values of the atomic molecule. Molecular weight is used in chemistry to determine the stoichiometry in chemical reactions and equations. And then in polymers, we also have a molecular weight. In polymers, molecular weight takes on added significance. That's because the polymer is a large molecule made up of repeating units. The variations introduce some unique aspects of polymer molecular weight, since polymers are made up of smaller molecules called monomers. The length of a polymer's chains and the extension the molecular weight depend on how many monomers have been linked together to make the polymer. So if you can see in the photos, you can see the small molecules and the length of polymers and the process of polymerizations. And then we have the application of structured polymers. So it consists of five of examples. There's a polycarbonate, polyurethane, polystyrene, polyphenol chloride, and lastly polypropylene. So first, polycarbonate. Polycarbonate is a long-chain compound formed by functional groups linked to carbonate groups. It is considered the thermoplastic since it can be molded when heated. The main applications of this compound are in CDs, filters, bottles, and containers. Next, we have a polyurethane. This polymer is composed a chain of organic units connected by the urethane links. This option is widely used in metal sheets, car upholstery, thermal insulation in waterproof coating, casing, and films. And then we had polystyrene. Polystyrene is a homopolymer formed by the polymerization of the styrene monomer. It is a part of the thermoplastic polymers examples, which give it its greater flexibility. It can be used in the manufactures of thermal insulations, air conditioner fan covers, and doors, and as well as in machine and automobile parts. Next, we have the polyvinyl chloride, or we can call PVC. So polyvinyl chloride is one of the most produced synthetic polymers in the world. It can be characterized as the rigid or flexible. It, the main applications are in the partitions, transition roof tiles, pipes, and connections for waters, and window blinds. And the last one, we have the polypropylene, or we can call PP, belonging to the group of the polyolefins, polypropylene, also called polypropylene. It is a thermoplastic compound produced by the polymerizations by adding the polypropylene monomer. It can be applied in container for food, chemicals, fibers, and hospital materials. Okay. And lastly, there are some reference about this topic. And thank you and have a good day. And wassalamualaikum warahmatullahi wabarakatuh.